If I ask you to identify the pattern of how does a matrix on the left side transform into the matrix on the right, with as little as just one example, you'll probably be able to figure out the pattern and generate output on the right side, which looks something like this. And even for some more complicated example like this, with as little as 2 or 3 different examples, you'll probably be able to identify the pattern that it is taking the smallest rectangle shape, output just that, which means now you are able to answer this new question. Those seemingly intuitive and simple tasks that you can answer is something that state-of-art large language model like GPT-4o will be very struggling to answer because those information are not part of the training dataset. Even though large language model has shown impressive ability to solve problems, especially with the recent agentic behavior, where it is capable to generate complex code or explain deep concepts, it is fundamentally very poor at handling new things that it wasn't trained on. Because the way large language model works is basically trying to predict the next word based on the probability within its massive training dataset. And the reason it can answer some basic math question or things that require some logic and reasoning is not necessarily because they actually think things through, but it just memorize it and spit out the answer based on its memory. And some might argue that this is not a showcase of true intelligence, but more a showcase of strong memory ability. And that's a big difference, because many believe the definition of true intelligence is the ability to adapt and learn new things. As a Swiss psychologist, Sean, mentioned, intelligence is what you use when you don't know what to do. If we always just rely on past experience and knowledge, no matter how big the amount of data we can ever have, it will always be limited by past experience. As human, we won't really have breakthrough to learn how to use new skills and tools never seen before, because it was not part of the training data. But if you put a baby or kid in a new neighborhood, even though they never gone through any training, able to adapt the new environment or language without pouring millions of training data in. And that is ability to solve problems that it never seen before, with very little training data. This exact problem has been described by Francis Claude back 2019, where he published a paper called On the Measure of Intelligence, where he introduced a benchmark that we can use to measure the efficiency of AI skill acquisition on unknown tasks, called ARC, which represent for abstraction and reasoning corpus. This benchmark is basically a collection of unique training and evaluation tasks. Each task contains multiple inputs and output examples to showcase a pattern. And the puzzle-like inputs and outputs present a grid where each square can be one of 10 colors. And the goal is to build an AI system and will be able to predict exact output based on a new input. Some of them might feel simple and straightforward, but many of them are actually not as straightforward and can be quite complex, and also cover a wide variety of different type of tasks that is fairly unique compared with each other. And those tasks didn't require any prior knowledge. It's a pure test of its raw intelligence. And ever since this benchmark was introduced back in 2019, there were many people trying to build AI system that can complete those puzzles. Back 2020, the best performing AI system was able to answer 20% of those tasks correctly. And the latest version till now, June 2024, is 39%, which we will dive a bit deeper into their methods. But meanwhile, back 2021, New York University actually did a study to get a human benchmark. According to that study, an average human is able to answer 84% of all the puzzles, which means if we have an AI system that can achieve similar level of performance as human, that means we actually build a system that can learn and adapt to all sorts of different new scenarios, just like humans do. And that is basically the goal of the ARC AGI competition that is happening right now. It is global competition everyone can join, and whoever build an AI system that can achieve superhuman level performance, which is 85% correctness of the ARC testing data set, will be winning the competition. There's total amount of 1 million prize pool for the winning teams. And what does this actually mean? Let's say by the end of this year, that someone build an AI system can actually achieve this. And this is what François said.
Given that ARC is a minimal reproduction of general intelligence, how important is it once we discover a solution?
So at the very least, I think a reliable solution to ARC would be, at the very least, it would amount to a new programming paradigm. If it works on more domains than just ARC, then it means that you found a way to, given just a handful of input-output pair demonstrations, produce a program that matches what you described with your examples. And because you only need a couple examples, it means that anyone is now able to program computers by just describing, here's my input, here's my output, and do this twice or 3 times. And now they have a program that they can run and that will generalize to new data in very much the same way that a human that has seen the same examples would generalize. And hopefully that's AGI. But if it's not, I think it's at the very least revolutionary new programming paradigm that will make everyone a programmer in a much truer way, I think, than LLMs that basically spit back code snippets that are similar to things they've read on GitHub or Stack Overflow.
So this is a really exciting project and going to help on the progress towards AGI massively. But what are the all different type of approach and methods people have tried so far to build such AI system that can adapt and learn new things? So I'm going to share a few examples about how different teams are trying to tackle this problem, as well as how can you participate. But before we dive into that, I know many of you or your company actually have a huge amount of data that can be analyzed or can be leveraged by AI to extract additional insights, but not exactly sure how can you do it properly because there are just so many different unknowns and it's not very clear what is best practice in terms of like choosing the right data set to use, projects to prioritize, or how can you pitch those projects internally. That's why I want to introduce you to a research that HubSpot did, where they interviewed lots of different people from top companies about best practice of how they are integrating AI into their data analyst workflow. It showcased common challenges and pitfalls that you might experience when adopting AI into your data analysis process, as well as some best practice process about how to start and plan such projects within your company. It even includes a comprehensive checklist for specific things like how to ensure data privacy and security while you are sending data to different large language model and AI systems. So if you're planning to leverage AI to analyze data in your company, I definitely recommend you go download this free research and get more prepared about things that you need to do to launch such project. You can click on the link in description below to download this report for free. And now let's get back to the ARC AGI project. So how does it actually work and how can you participate? If you go to Kaggle and search for ARC Prize 2024, you have this page where you can join and submit prediction. And in this project, it has a data set. If you look into this data set, it has both evaluation, training, and the tests. And evaluation and training are basically two different data sets that you can use to build the AI system, where the training is a bit easier and evaluation is a bit harder and more difficult tasks. Each challenge in those files has both test and train. And if you open them, they are basically input and outputs, and each are a matrix of numbers that is representing the chart. So basically, each visual chart is represented in list of array like this, so that you can feed to different systems like large language model. And each dataset looks something like this, where the training basically is 3 or 5 examples that it is provided to help you identify the pattern, where the test is the actual challenge. So you can use basically all those training dataset and input from test as the input for the system. And the goal of system is to be able to generate an output that is exactly 100% match to the correct answer that is provided here. There are loads of different challenges that you can use to train and test the system you're building. And that's pretty much it. You can start trying different approach and methods to try to tackle those testing data sets. And I'm going to show you very quickly how can you set up some basic environment to start building the system. So if you go to Kaggle and click on Create New Notebook, you can click on Add Input and just search for ARC Price 2024, and there will be one of them. You can click on that to add to your notebook. If you close that, you will see that there's one input called ARC Price 2024, which has all those JSON files that we will need. And what I'm quite curious is, I want to test what's raw ability from large language model to try to solve this problem. Even though large language model itself is system one fast thinking with just pre-trained data, but there are a lot of techniques that could be used to actually increase the reasoning ability. So I'm quite curious to just try it out and see what kind of raw ability output would look like. And that's what I'm going to do here. So firstly, we want to load the data. So I will import a few different libraries and create a function to split tasks that have multiple different task input output pairs. And this will make handling a bit easier. Then I just run a quick function to load the evaluation dataset. And here what I'm loading is the evaluation dataset, which is the one that's a bit harder. And in the end, I will create a panel data frame. Okay, and last, we can just try it out to see how the dataset look like. So if I do dataset 0, you will see that each dataset looks something like this. It has training with input outputs, examples, as well as test data, including an output that we can use to verify. And that is what we're going to do next. I want to create a quick function to be able to validate whether the generate answer is correct or not, as well as some help function to extract the answers. And to do that, I will first install a few libraries. I'm going to use OpenAI for this test. But just be aware, when you actually participate in the competition, you are not allowed to use OpenAI model because there won't be internet access. So you have to use some open source model. So I'll create a few different functions to extract the final output generated by the system. Because if I'm using large language model, the answer might include all sorts of different things like the reasoning itself. So I need one function to do exactly that. And then I'll create a function to be able to compare the result generated by the AI system versus the correct output from the dataset. And output if it is 100% correct or not. And that's pretty much it. Now we can start building functions that can take in the testing dataset to generate answer and compare the result. And firstly, I'm just going to try some basic vanilla language model call with GPT-4o. So I will create a function called solve single language model, where it will take in the task and a few short examples if I have any. So I create a system prompt where it will take in the few short example if there's any, and then show the training data and in the end input data. And here I didn't even ask it to do the chain of thought. So it's very basic large language model call. And then I will just take one challenge data set, get the true solution, generate answer from a large language model, and then compare the results. In the end, output the final result. I click this. Okay, so we got answer. So this is sort process from GPT-4o. The final output is this one. And we can see that it actually answered correctly. Correct percentage is 100%. And if we check this file name, which is 005762224, this is the actual visualized challenge. You can see basically it will just repeat the pattern multiple times, and it is actually answered correctly. So that's pretty good start, but let's try a next one to see how well it performed. And this is the second one. From what I can see, it basically just takes the biggest shape and the color is differently. Assume the color is based on the actual number with some transformation. And if we go back to the notebook, you can see that the answer here is incorrect. And GPT-4o vanilla, it output both shape and as well as color wrong. So obviously there's some limitations with direct large language model call. And my question now is that were some traditional prompt engineer tactics like multiple large language model chain or agents or even multi-agents going to help in this situation? So I'm pretty keen to just try it out. So this second thing I'm going to try, basically the idea here is instead of just getting through one large language model call, can I increase its intelligence by break down into two steps? The step one will be just looking at the examples and try to identify the pattern. And step two will be trying to solve that. So I will have a first large language model call to identify the patterns and explain the transformation that it observed from input and output. And then I will put this rules as part of prompt to a second large language model call. And this is basically the idea. And let's see if it actually improves the reasoning. So I will basically do the same thing, but swap the function to be this new function that I created. Okay, so now we get the answer. And if I look at it now, I can see the reasoning actually improved compared with previous one. Because if you see the result, it does remove all small symbol from the output, which in the previous one, it totally ignored this rule. But the part it got wrong is the color of the actual shape. And this, to be honest, is a bit challenging. I don't even know what the rule here is, because it looks like there are different colors based on different shapes. And if you look at reasoning step, it did actually capture that. So it captured a few different rules. One is number A represents some particular structure that needs to be transformed, but it just wasn't sure what's the rules there. And each input grid that contains one, which is smaller one that should be removed from grid after. And what I want to try next is I want to see whether a multi-agent system can actually help in this situation. And in my mind, that the next idea is whether we can build a multi-agent system to improve the reasoning here. And one key concept here is that instead of getting a large language model to generate answer directly, we can actually get a coder agent to write a piece of code that can do this transformation. And the benefit of that is that then we can get a program verifier agent to run this code against example input-output pairs to say if the program actually delivers the result that we want. If so, use that program to run the result. If not, give feedback back to the coder to actually iterate code. So this kind of the concept, I'm pretty curious to see whether it works. So for that method, I'm going to use autogen to set up multi-agent system. So I'll install autogen package and then set up a multi-agent system. So I'll create some temporary folder to store the program that's generated by coder. And I will first create an agent called pattern identifier, whose role is specifically to identify the pattern and explain what the requirements that the program should meet. And next one is I want to create a coder who will actually generate code. In this code, I wanted to take two inputs. One is input grade and output grade, where output grade will be an optional param. And this program should run the code and then return whether the program running correctly 100% match or program is incorrect. And in the end, I will write a program verifier who will play the role as QA and run the code against all the examples, inputs, outputs pair. Any of those input-output example pair return incorrect, then give feedback to the coder to iterate code. And if the result is actually correct, then run the test input and return final result terminate. This agent should be able to execute code as well. So I will put a code execution config. And in the end, I will put a user proxy agent and create a group chat as well as define a group chat manager. So that's pretty much it. I will do the same thing to run this code. And in this case, you can see that it will pass on to a pattern identifier, which in this case successfully identify a requirement for the code, which is it should map the value 8 to a new consistent number and remove all the other value that's not 8. And then the coder start generating code that can meet this criteria. If output grade is not known and the result is 100% match, then it will return program running correctly. Otherwise, it will return program incorrect. And then the program verifier start running this code multiple times against the examples. Instead, it seems that the output has successfully returned the results. In the end, even though the program verifier error out, for some reason, the answer is correct this time. And if you look deep into the program it written, you will realize that this program probably is not correct because it is always mapping 8 to 7, a specific number, which is probably not true. So let me just try to run again. Okay, in the second attempt, it seems still not very good. I just keep failing generating the whole program for some reason. But I can clearly see that this method 3 internal reasoning steps seem to be more reliable than the other two methods. And later, I did read an article from Ryan, who achieved 50% score on the public test dataset. And the method he was using is actually very interesting. So in nutshell, the method he was using is also getting the large language model to generate code to actually answer the question. But instead, it is a lot more sophisticated with a lot of optimization. So it will give the large language model, which is GPT-4o, both the image representation of inputs and outputs, as well as text representation. And first, it allows the language model to reason and plan what kind of code should be written. But the next step is instead of it write once or use a kind of agent to iterate multiple times based on one piece of code, it gets the agent to run 3,000 to 5,000 different attempts to get large language model generate the code. So this is a crazy amount of the exploration and generation. And from those 3,000 to 5,000 examples, it pick up 12 batch programs and then run against example input and output to verify. And if there's any error, it will iterate. So the high-level idea is actually similar, but the crazy part is it generates huge amount of codes. And also looks like multimodal can lead to better reasoning in this example. And I took a look at his GitHub. It actually a few short prompt examples to teach large language model how to explain the image and text representation of the challenge, as well as the Python code example too. And this method of exploring a huge amount of possibility is something we normally call discrete program search. It basically is this process of getting the model to search and explore massive amount of different options. Then do the check to verify which option actually leads to the right path, like running the code to verify the output, and in the end to select the ones that actually worked. It's a similar concept that AlphaGo adopt where it explores a huge amount of different paths and possibilities. So this seems to be a really effective method, except this is going to burn a huge amount of cache to run such a program. And Francis also posted a tweet to talk about this. He said the main issue with program synthesis, which is basically this program search, is combinatorial explosion, which means the space of all programs grow combinatorially with number of available operators. And the best solution to find this explosion of all the possible paths is to leverage intuition over the structure of program space, which means you can probably fine-tune a specific model to sample a program and suggest the right branching decision. So instead of exploring all the possible different paths, you can use certain model to help deciding which path is more worth exploring versus others. And even though that intuition or judgment might not be correct, it will still guide it to a more plausible path with much more efficient structure. And he actually has a Google slide that explain a few different concepts in details. I put the link in the description below where you can click on that to check more details. And on the other hand, I also noticed something that called active inference that seemed to deliver really good results with the language model. And the concept here is basically using synthetic ARC AGI-like data to fine-tune the language model during the evaluation stage. And here's a quick clips where Frenchers talk about this specific method.
The trick to making this LLM-based solution work. So the thing is, if you take a state-of-the-art LLM and you additionally pre-train it on millions of synthetically generated ARC-like tasks, that still doesn't work very well at all. It's maybe on the order of 10%, so not very good. In fact, much worse than relatively basic discrete problem search solutions. And the trick to actually making this approach work well is active inference, which is this idea that when you're presented with one of the test tasks that you're supposed to solve, so you're presented with a small number of input-output demonstration examples. And the idea is going to be to fine-tune the LLM on these examples. And of course, because you only have a couple of them, that's not really enough to get stochastic coherent descent to work. You're going to want to expand them artificially using a DSL that's going to just apply transformations to them. So trying to make them more diverse to have basically enough data points to fit a curve, but still trying to make them match original task. And this trick of doing active inference via fine-tuning is actually what unlocks the performance of this approach. And I don't think this is something that I've seen with LLMs before, actually. I don't think anyone else is doing that. And the fact that it has this outsized impact on the solution, I think is really interesting. And it feels intuitive that LLMs are not on their own the solution, like LLMs near things like Gemini or ChatGPT and so on, because they're basically frozen at inference time. They're not actually learning anything when you show them a new task. But that's not how humans operate, obviously. When you look at a task, you're forced to adapt to it. You're not just fetching something from your memory that matches this task. If it's a task you've already seen before, then sure, maybe that's what you're doing. But the idea is that you can be exposed to these tasks that you've never seen before, and you need to make sense of them. And so you need to basically learn from them, right? You need this active inference step, which vanilla LLMs are not doing. And I think that's really one of the big blocks on their performance, especially on ARC.
So those are a few example implementation of how you can attempt to solve the ARC challenges. And the key thing here is that the real breakthrough hasn't even shown up yet. So there's loads of methods that you can try. So I definitely recommend you to go ahead and play. You can go to Kaggle ARC Prize 2024 to just join and submit your solution. If you want to find some example, you can go to code. There are some examples already, like this Llama 3 AB example that you can use as a reference to see how to upload the solution you did. I'm really keen to see what kind of interesting solutions that people are start exploring. This is definitely a project I'm going to continue monitoring. I'm quite interested to try the methods of fine-tuning with synthetic data as well to see how well the method can work. If you do want to keep update, please comment below about interesting methods that you heard or tried. I'm really keen to discuss more on this. And if you want to keep update, please subscribe. Thank you, and I'll see you next time.